Special relativity.
Yeah. Do you have?
What is it?
That's okay. What is special relativity? All right. I'm gonna take this from a historical, like where it came from. So like, the way we've always understood motion, it's like speed is additive, which means like if you're driving in a car, right? Let's imagine we're in a car, and we're going like 10 miles an hour, right?
Very slow, correct.
Yeah, we're moving though,
That's how I drive.
and just going 10, cruising. I like it. So we're going 10 miles an hour on the road, and we throw a ball out the window forward, and we could throw the ball at 5 miles an hour, right? So if I'm going 10 and I throw the ball 5, how fast is the ball going?
15.
Very good. Yes, 15. Because the
Don't
speed.
put me on the spot
Sorry.
ever again, nerds.
I figured 10 times 5 is okay.
Yeah, it's fine.
10 plus 5. 1 times 5. Okay, so
15.
ball's going 15, right? Exactly. Because the car's going 10, the ball's going 5, so it just makes sense. That's the way we've always understood everything. You know, like speed. It's like you measure something relative to a frame of reference, right? So like from the frame of reference of the floor, you're going 10, you throw it 5. Compared to the floor, the ball's going 15. Like motion doesn't mean it unless you pick a reference point. You know what I mean? Like if you're moving, I'm kind of getting off topic, but that's okay. If you're moving and you, like imagine you're in the car, right? And someone's going the same speed as you next to you. Compared to you, it looks like they're not moving at all.
Yeah.
Like everything else is moving.
Yeah.
So like, all right. Okay, so speed adds, right? Now, a guy by the name of James Clerk Maxwell, I think his middle name was Clerk, or Clark, one of those two. He realized that the speed of light is constant. It's always the same speed. Like he realized, like what he did was he worked in theoretical physics with figuring out that light was a wave. He figured out that light was a wave, and compared it to, and then through his theory, like working it through, he calculated the speed of light, and it matched with existing experiments of calculating the speed of light. So like the fact those two numbers match, he found that the speed of light's a constant.
James Clerk.
Yeah, Clerk with an E.
Was it Clerk with a what?
So it's James Clerk.
Maxwell.
Yeah, look up Maxwell. Came up with Maxwell's equations, which are cool. Gotta stay with relativity. I'm going off topic.
Correct.
So he realized the speed of light's constant. He almost discovered special relativity. James, if he made like the mental leap that Einstein did, he was right there. He was like ready. The speed of light's constant, right? So fucking Einstein comes along, and it bothers him that the speed of light's a constant. And let me explain why.
This fucking constant.
Yeah, it bothered him, right? For a long time. So let's go back to the car example, right? You're driving your car. You're driving 10 miles an hour, right? But this time, instead of throwing a ball, you turn on your headlights. How fast is the light coming off your headlights?
How fast is it, John?
You would think that it's the speed of light plus 10, right?
Yeah.
Because you're already going 10 miles an hour and you shoot the light off. Sorry. I'm trying to talk to everybody. Like I felt like I was being impolite. So
They don't exist.
All right, they don't exist.
Ignore.
All right, just me and you chilling in the garage.
It's just me and you. There's not even recording equipment. There's not two people smoking cigarettes behind you.
Oh man. Can I have a drag on that?
Just me and you.
Thank you.
What
This
if
is a
you
good idea.
moved his chair there, facing the lake?
Thank you. Oh, that's
You
nice.
can't. Anyway.
All right. So you shine the headlights. You would think it's the speed of light plus 10, right?
Mm-hmm.
But it can't be because there's nothing faster than the speed of light. Nothing. That's like the universal speed limit, right? You can't go faster. So what's happening? You know, how can the speed of light be constant but you could go 10 miles an hour? All right. So I'm gonna give you an equation. Is that all right? Are you cool with that?
Go for it.
Okay. It's not that bad. It's just we have to figure out, like, in order to figure out what's going on with those headlights, we have to know what speed actually is, right? Like, what is speed? What do you think speed is? Yeah.
How fast stuff goes.
Okay.
Distance over time.
Yeah, that's what I was looking for. Right. Distance over. Well, yeah.
I thought you were giving me the equation.
Sorry.
And asking
I was trying to get out of your head. I know it was in there. It's okay. So it's like, no, think about it. Like, when you drive in your car, what do you measure your speed in going? Like what
miles per hour.
miles per hour, right? A distance per time. When you say per, it's like distance over time. So how fast you're going over a period of time, right?
Yeah.
How much distance you travel over a period of time, right? You're going faster, more distance over a period of time, slower, less distance over a period of time, relative to some whatever. Okay, that's what speed is. So if the speed of light is a constant, so speed is equal to distance over time, right? You got me? Wait, where did this come from? I forgot. I don't remember
Speed
putting that in
is
my
a
head.
constant that can't change.
Right.
What else in that equation can't change?
Okay, so speed's constant, so then you're left with distance and time. The way we've always thought about distance and time is that distance is just like where it is, and time is like when it happens. Like, they're separate things, right? And that's how, like, everyone thinks about everything, because it makes sense in our world. Like, we're slow moving, we're going nowhere near the speed of light, right? So distance is just like how far me and you are away, and time is whatever. But, like, the big thing about relativity is they're connected. You know, you can't take them away from each other, and it kind of makes sense because, like, we can't teleport anywhere. You can't be somewhere else next instant of a second. It takes you time to get over there. Moving through space, you have to move through time as well. So, like, right now we're not moving through space, right? We're chilling relative to the floor, but time is ticking on, so we're moving through time, right? Okay. I was going somewhere with that. Hold on. Okay, distance over time, right? So they're connected. If speed has to be constant, the only two things that could change now is distance or time. So when you start going, so when this car now, man, okay. So if you start moving closer to the speed of light, you have, like, the speed of light has to be constant from every frame of reference. So from the headlights coming out and from the ground, it has to be the same speed. And the only way that can match is if we change distance or we change time. Does that make sense?
Yeah.
Okay, you with me?
Yeah.
Okay. How are you doing so far? Any questions? No? You're good?
The floor is yours.
All right. So, okay. So what happens is when you start moving close to the speed of light, distance gets weird and time gets weird. Along the same direction you're moving, length actually gets shorter. Length contracts, and that's not a measure of, like, the material itself. Like, the material doesn't get smaller. It's like distance itself gets smaller. Space itself gets smaller in that direction. Does that make sense?
Do we understand how?
The reason that is because the speed of light has to be constant. Like, that's the best explanation we have for it. So the only thing that can change in our equation, right? We have speed is distance over time. If this can't change, we can change distance, right? If this has to be constant for both of us, in one frame of reference, the distance is normal, and the other one is just smaller in order to keep this constant. Does that make sense? That's called length contraction, or the Lorentz contraction, because some guy with the last name Lorentz, I think, discovered that. I like that you're doing, like, pulling the stuff up. That's cool. Anyway, so length contracts, and then, but also time dilates. Like, time ticks slower, and there's not a problem with our clocks. It's a problem with time itself. It ticks slower. Does that make sense?
Yes.
Okay. So length contracts. So in the frame of reference of a photon, like a particle of light coming off, right. In the frame of reference of light itself, time doesn't exist. Time is, like, effectively infinite for it. It's everywhere, like, instantaneously in comparison to the light itself, right? And length in the direction it's moving is flat. So, like, from a photon coming from the sun, from the frame of reference of the photon, the Earth's completely flat because there's no like it doesn't even make sense to measure things in this direction anymore. Does that make sense? So, and the best, like the most important thing about this is it's experimentally verified. It's not just like a crazy idea that Einstein had, like, like speed of light's kind of like all this stuff happens, length contracts, time dilates. It's been experimentally proven. Like GPSs wouldn't work if we didn't understand special relativity, because you have to think about it. The GPSs are using lasers to bounce everything, and those lasers move at the speed of light. So if it wasn't for special relativity, we wouldn't be able to like triangulate where we are. Does that make sense with the lasers? So the fact that it's like the crazy thing about it is it's like a mind, like it doesn't make any sense, right? Because we experience everything how we experience it. Like this is far away. This like length doesn't change. It doesn't make any sense. Like length is absolute, time is absolute. There's always like a second, but it's relative. It's relative to how fast you're going. Time is different and space is different, is depending on your speed. And that's been proven. Like in planes, time, like clocks tick slower because they're going faster than we are. And our clocks are precise enough that we could measure that distance. It's measurable, the difference of it. You know what I mean?
Mm-hmm.
The closer to sea level clocks are, right?
Yeah.
Or the further from sea level, the slower they dip.
Right, and that's true, but that's because of
Wait.
general relativity, how gravity affects time, not special
You're
relativity.
probably gonna need to say that into the mic. You can't.
Then I did it.
You heard Cal?
We're good. Yeah, and that's the most important thing about science is that it's not just the crazy idea. You need evidence to back it up, or else there's no point in really talking about it. Not there's no point in talk about it, but that's not what science is. It's all about like presenting an explanation for things, and using what we've found, what we've measured as evidence for that explanation. Does that make sense? Like I guess that's transitioning now we're in science. We're talking about normal science.
Moving on to science. What is science?
Okay. Well, wait. Do you have any questions with special relativity before we move on? How you feeling with it? And and it's so important to like, if you have a question but you don't want to ask because you don't want, like, I think it's important to really ask questions. You should ask if you have them. Do you have them? Do you have any questions? No. Okay. I couldn't have put you on the spot more than I just did.
Yeah, I keep telling you, it's strike 2. I'm gonna ignore the questions.
I'm like,
bit.
no, listen, you should really ask questions. It's so important to ask questions.
Yeah.
Do you have any questions? No, I'm sorry, man.
It's
All right.
usually, like, I'm gonna listen.
Okay,
I'm gonna try and keep you on track.
I feel you.
I will back you up as best I can. I don't have
All right.
questions.
Okay. So, let's talk about science.
What is science?
Can
Question.
Can I put you on the spot one more time? When you think of science, like, what do you think of?
Oh, I think of Nazi dentists. No,
Oh.
No.
That's it's really particular.
No, I think of I have a fucking car, I think
Yeah.
of this light bulb,
Right. Like
a lot of
technology,
good
right?
things
Like,
that happen.
totally, man. A lot of good things that happen. Like, a lot of good things come out of science, totally. And I agree with you 100%, and it's awesome. But that's not why we do science. Does that make sense?
Sure.
It's like the engineers are all about making what we know work for us. You know what I mean? Like, build something. I guess it's interesting how, like, you label each... Like, we're kind of doing similar stuff, but, like, the engineers are making science work for them. Where scientists are trying to figure out how the world works. At its most fundamental level,
Yeah.
So, like, we don't do science just to get stuff out of it. We do it because, like, we want to, as humans, all of us, want to understand how things work better. They just want to understand the universe we live in. We've always, since we've started evolving, that's what we've always craved. We want explanations for things. That's why, like, people come up with, like, gods and things. They want to explain what they're seeing. Like when you hear thunder, you're like, oh, like you don't know what the fuck's going on if you don't know weather. You know, like if you like, no one understood that. No one understood how weather works. They don't understand like cloud formation. They didn't understand that like what rain is, like where it comes from. So their explanation for it was, there's got to be something big up there making noise. Like that's all they could think of. You know what I mean?
It's banging a drum.
Right. So, and that's how they explained it, because that's what made most sense in their world. But as we lived here and as our brains developed and as we started so we've always come up with explanations about things, but it was a really important time in human history where we didn't just come up with explanations, we tried to come up with explanations and have measurements and things that we see and touch and feel like explain that. And not only that, but trying to explain things using being as critical of that thought as you possibly can. Like when you come up with an explanation for something, you take that thought and you don't try to figure out why it's right. You try to figure out every reason it could possibly be wrong. Anything that can make this wrong. We got to
segueing into the scientific method.
Yeah. Yeah, we are. Yes, we are. So every way we can make that wrong. So like we think of, I gotta think of an example. I'm talking too abstract. Let's talk, okay, atoms, the atomic theory, right? When that was, like, we all know today that everything's made up of atoms, right? I'm going to get into, like, we can never really know anything.
Sure.
We're going to talk about that. We'll get there. Right. We know atoms exist, right? But there was a time where that was a new idea. And it was not even a new idea. It's been around for a long time. But it was an idea that we didn't even consider really that it explained anything. Does that make sense? We thought, like...
It was like, duh?
Yeah. See, the Greeks...
like, no shit, we're made of atoms.
Listen... I'm going all over the place, dude. We're going to the Greeks, man.
We're going to the Greeks.
We're going to the Greeks.
To the atoms.
Wait. No, because they're the first people who thought that atoms, that things, that you could cut something to its fundamental, indivisible bottom. Yeah, so like you have this chair, right? I could cut this chair down to the most fundamental unit of chair. You know what I mean? Yeah, so that word atom is Greek, actually, and it means indivisible. Isn't that cool? So it means indivisible, and but the thing is, the reason why Greeks weren't scientists, like that sounds like super scientific, right? Like, oh man, they came up with atoms. The reason why they weren't scientific is they didn't test that idea. They're just like, that's the way it works.
Sounds right.
Yeah, and then they would move on with whatever was going.
They were philosophers.
See, science understands that we are flawed. We don't have a perfect reasoning system. None of us do, you know, like, so they're coming up with a method to totally get rid of as much bias and as much fallacious reasoning as possible, like coming up with what's actually happening, independent from how we could like perceive it wrong. Have as many people look at it as possible, have a lot of people like check our stuff. Doing like statistical analysis to it, doing like triple blind studies. You ever hear like on a double blind study like this happened? Would you ever figure out, like, do you ever like wonder what those blinds mean? It means that they're trying to make that they're getting as much known out of the experiment as possible. Meaning,
give you a Tylenol and a sugar pill.
Yeah, right. That would be, yes, exactly.
My
So
headache went away.
right. So a single blind would be that the experimenters like don't know if they're which group they're giving the medicine to and which group they're giving the placebo to, right? That'd be like a single blind. A double blind would be that the person doesn't know whether they're getting medicine or the placebo, right? It's adding like removing humans, like possibly affecting the results, right? A triple blind is the people analyzing the data don't know which group is the Tylenol, which is the sugar pill. You know what I mean? Just removing everybody from it. So
It's a quintuple blind
Yeah.
study.
So what you're trying to do is you're trying
Everyone's
to
actually blind.
right. So anyway, you take these ideas and you hit them so hard with as many ways you can disprove it as possible. And when we can't disprove it, we're like, I mean, I guess that's it for now until we figure out a way to disprove it, you know? Science is never about fact. And it sucks because in school,
It's about potential fact. Oh, man.
dude, in school
It's almost true.
yeah, right,
So
exactly.
somebody goes, no, it's not true
Right.
no more."
It's conditional. It's conditional truth. This is what we believe right now because all the evidence we currently have, we're trying to get much more as we can. And if we get more evidence and explain something different, we change our mind. That's the biggest thing about science is like, you know? So
Provable has to be
testable
provable.
and falsifiable.
You got to be able to do it every time.
Yes, right.
If it doesn't work one time and they can prove that they did it right,
Yeah.
then it's no longer
Exactly.
No longer true. Shit,
Right.
It's wrong now.
And then we need a new way to explain that.
That's my favorite thing. Actually.
Totally. Okay, so, but at the end of the day, something to keep in mind though, we're still humans doing it,
Yeah,
you know?
we can screw it up.
We're doing the best we can though. It's the best we can do. This is the best way humans have devised to get new information
We're
and
tree
explain
creatures.
things.
We made it to
Yeah.
space
We made it to space with this, you know?
from a tree.
From a tree.
From a goo.
Yeah,
Or
totally.
goo at one point, I guess.
Right. Yeah. There's like that's a whole other thing. Like where did life come from? We got to save that later video.
Episode 105.
Later video where
Don't worry
life
about
comes
it.
from. That's a discussion.
He's gonna
though.
get so
Oh,
drunk
I'm
trying
getting
stick figures. With speed and gusto.
yeah, totally. How long have it been going? Has it been going for a long time?
It's been 7 minutes. It's been 23 minutes.
Oh, that's not bad.
Yeah.
All right. How's everyone doing? We all good? Like, you want to keep going? Can we keep going?
Please.
All right.
You can go. Keep going. You have another hour until I'm just done. So use your
All right.
time.
Everyone's good though. Everyone's with me.
I'm fully on board.
All right, cool. All right, can I talk about just real quick? I know this might be a whole topic for another day, but like how in school they give you a test and it's multiple choice and it says one of these is right and the other three are wrong. And you circle it and you hand it in and like that's what people that's what people think science is and it's no bearing on the person at all. It's totally understandable because that's all we've been exposed to with science is school and how this is the right answer because I told you it was the right answer. And you're going to do this experiment to prove that I'm right. To prove that this thing I told you is correct. So you already have that bias that this is the right way to explain it. And then you check it and you're like, yeah, that's exactly what I expected to happen. Very cool. Right. That's not what science is though. Like science is a noun and science is a verb. Does that make sense?
Really quick. Every time he goes something like, "What is science?" and I say Nazi dentistry, please just cut that out.
No, we're keeping that every single
'Cause I may
time.
do it 100 more times.
Dude, that's gonna be the host. Is a Nazi
Kind of
dentist.
science, though.
Totally no.
But
And
no, please, every
that's
time.
okay. Another
Don't
video.
listen to him on that.
No, listen. Another video is like ethics of science, like whether or not we should know things, like whether or not we should do that experiment that could cause suffering to know something more. Like that's a whole other discussion. We'll talk about that another time. Episode 107.
176.
76. All right. Science is a noun and a verb. Science is what we know, what we understand currently today, but science is also doing the science, like we were talking about before, right? Like you can do science and you could know science. Does that make sense? So school's very focused on what we know now, but they don't ever talk about like questions we still have or what we don't know. And that's where science really exists, is what we don't know yet.
Other than that, you would just say that like
Right.
previous stuff is like learning the basics and the history
Yeah.
up until where it gets experimental.
So like this whole philosophy of how we like talk about science is so important for us as humans. Like it's like it identifies us as a species, I feel like, you know? Like the way we want to like I know probably every person who studies their subject thinks like that's the most fundamental thing. Which is totally understandable. Like the historian is like, yeah, but the history of when we started thinking about science, you know, like that's important. Like looking at the evolution of humans, and I 100% agree. But like you have to.
But it's
No, you have-
more compartmentalized. Than
Yeah,
that, isn't
but
it,
you know what though? You know what I just realized just now, just the second, is like it doesn't have to be so separate, you know? But at the end of the day, we're all doing the same thing. We're trying to know things, right? Like that's what every academic subject's all about, is knowing things. And like science wants to explain it one way, history wants to explain it another way. It's just like a different perspective of looking at the same thing that's happening, you know? But the very fact that we looked at this thing at all and tried to understand what's going on is, I think that's like fundamentally science. I just totally like contradicted the first thing I said. It's fundamentally what I think it is.
The duality of science.
Yeah, it's
some would
weird.
say.
Yeah. Good. Yeah. No, am I leaning too much? All right. So, okay. I got more things to talk about. You cool?
Go for it.
You good? All
What's-
right.
Where are we?
So, like, all right. Like, it's interesting to think of how we, like, the philosophy of science, you know? Like, what science is, like, as an idea, you know? That's, like, the whole idea, like, the philosophy of science. And there's two ways to really, well, there's a few ways to think about these things. And science is a part of, I'm getting, like, jargony, but I was reading on the epistemology, where it's like how we obtain knowledge, and that's what science is all about. Is like the best way to obtain knowledge is through measurement and like what we sense, what we could experience, you know. But the reason why science could never 100% explain things with certainty is we are 100% sure that we're not just a brain in a vat, you know. Like we're not 100% sure that there's not just a brain floating around that's like imagining us. Because like any explanation I could come up scientifically, like no, measure, like it doesn't. There's the measurement here, like it doesn't, like this is it's like that big, but it's like, oh well, the brain is just imagining it to be that big. You know what I mean? There's no way you could prove definitively that the whole universe wasn't created last Thursday. There's no way you could prove that, because any explanation I have, like no, these fossils are 10 million years old.
Nah.
They're like, nah, that was put there last, you know what I mean? Like, I can't 100% know that for sure. The whole point of science is not really understanding, not really knowing if it's true or false, but what we know about it, reducing the uncertainty of that, you know? And it's the best explanation that the place we live, like here, like this, we could all agree is here, and this is, like, the length of it is, like, what's true, you know what I mean? That's like, it's not true, it's like reducing the uncertainty of it though, you know? Mm-hmm. Like, I can't, I read a webcomic once, and it's the best, I laughed so hard, but anyway, so you're looking at me, right? You're looking at me. This is your world right now, like what's happening, but you can't see behind you, right? You can't, you can't prove that there's not densely packed Hitlers behind you at all times. You can't prove that to me.
That is totally based off of Plato.
Yeah, that's the cave, right? That's what you're getting at? Okay.
Plato
So,
knew about Hitler?
yeah. So, Plato had like a whole argument for this whole thing of like empiricism, like measuring things. So, I'll explain the cave real quick. So, imagine this is the brain in the vat is modern day Plato's cave. All right, so everything you understand, brain in a vat. Plato is like ancient Greece, and imagine you're a prisoner, right? And all you've ever seen is like the cave wall or like the prison wall and just shadows on the wall, right? Of people walking past behind you with the artificial light or whatever. That's all you've ever known your whole life. So you get up, you get out, and you realize there's a whole three-dimensional world out there. You know what I mean? You're like, oh shit, there's color, there's all this shit. You try to go back and explain that to the other person, like they'll never believe you because they can't even imagine that beyond, you know what I mean? Like that kind of idea. And it's like, well, what, like in so basically when you're a prisoner, your truth is everything that you could just see and measure, you know? Like that's your truth. But like there could be something else we just don't know. You know what I mean?
Yeah.
Does that make sense?
Yeah. This is essentially the idea that we could just be a thought in something's head. We
Yeah,
could
right.
be,
Shadows on a cave.
simulation in a computer.
Yeah, right.
It's statistically more possible that we're a simulation like 100 times down. A simulation of the simulation.
You read that recently? Yeah.
Simulations get so good that they can
Yeah.
make their own.
Right.
So it's statistically more likely that we're in a computer.
Right.
But
I
come
think-
on.
Yeah.
Come on, right?
It's interesting. It's like, yeah, I mean, it's maybe, you know, but like, as far as we understand and could measure right now is like, there's this universe and it started and it's going, you know, we can't prove anything about the multiverse. That's like the difference between conjecture and hypothesis and theory. Like theory is the best explanation we have for facts being like those measurements, right? Like the info we get in, theory is the best way we currently have of explaining that, right? But like the multiverse and string theory, like those are like it sucks that it's called string theory because it's not a theory. It's more of a hypothesis or conjecture. It's like there's hypothesis. We can't. There's no way we could test that idea. Like mathematically, it works out, but we're being pretty liberal with the math too, you know. So like that's like people believe that's the way it is, but the problem is if you're a scientist, fundamentally it has to be about measurement and testing, and we have no data for string theory, you know. We just have, from what we know now, like the math goes to that, which I guess is kind of like evidence, but I don't know, it's kind of indirect evidence, you know.
We can't like physically do it.
Right.
We just be like, yeah, it works.
Right.
Math around it works.
Exactly.
It's like saying that
Like-
you could perfectly still swing this golf club.
Right.
It's gonna go in the hole.
Exactly. Like string theory.
The math works.
Yeah, string theory. The math only works if 11 dimensions exist. That's the only way string theory works. And that's taking a huge mental leap, like logical jump. Like going back to the whole cave thing. Like, yeah, I mean, maybe there's 11 dimensions we just can't fathom. So like for us, it can't exist. But it's just that taking a big jump without having evidence to support it. But the math works out when there's 11 dimensions. So maybe there's 11 dimensions. That would be, I guess, one of the testable things about it. But how do you test if there's 11 dimensions, you know? That got pretty crazy. I just realized we were talking about the 11th dimension, dude.
So you don't believe in other dimensions?
I mean, my whole thing is maybe. There could be. There's not much evidence for it yet, but it could be an explanation for
We
it.
know there's at least 3.
Yes, we could measure in 3 dimensions. Time itself, like people think the 4th dimension is time, but remember we were talking about before how space and time are interrelated?
Yeah.
Like the only way for it to be an independent dimension is if it's independent. If like you could move along that dimension without moving along the other ones. Like think of like X, Y, and Z. Like you can have a point move up and down only and not move in the other directions, right? That's independent of the other 3 dimensions. Time is interwoven with these. Like you could talk about this, so like they talk about it as like 3 + 1 dimensions, which is kind of confusing, but the reason why I have to say it like that is because time isn't completely separate from distance.
Yeah, it's chilling with us.
Right, like remember we said before how we're stationary when we're moving through time, right? I lied to you a little bit. I had to explain it that way because it made sense for the idea we were talking about, but we're talking about a whole new idea and we came back to like the crossroads of it, dude.
Using science for your own gain?
Oh man, maybe. To help you understand it a little better though. That's my gain. My gain is for you to learn. All right. So we are moving through time and it seems like we're stationary, but we're stationary relative to the floor.
Yeah.
But the floor is moving relative to the center of the earth, right? And the earth is moving relative to the sun, right? And the sun's moving relative to the center of the galaxy, right?
Oh, jeez.
And the center of the galaxy is like, there's no inertial frame of reference. There's no like completely stationary frame of reference. There's like, can't think of one, right? There's nothing that could be completely stationary. Center of the universe, maybe, like but is the universe moving? Like, you know what I mean? And where is the center of the universe? You don't even know if that makes sense. They don't even know if that's a makes sense of a question to ask. Does that make sense?
It's like, why aren't the fish in the tree? You should know better.
Right. So no inertial. So it's like we're moving through distance and time at the same time. There's no way that you can move through one, not the other. Is the whole idea. So 3 + 1 dimensions. What were we talking about? Like, how'd we get here,
Dimensions.
dude?
I asked you if you even believed in dimensions. You were starchly against there being anything other than.
I'm not starchly. I'm not start. I am fairly certain with evidence we have today that we don't have any data for it. It's kind of like the whole, like, we love explanations as people, as humans, you know, like we love coming up with explanations for things. But I think my whole idea is don't come up with an explanation for it until you have data to support it, if that makes sense. It's like, make your explanation based on the data, not based on what you think it could be, and then find data to support it, if that makes sense.
You're saying that everyday people should potentially research things?
No, I think as people, we have to trust that people are doing science as best they can. Because, like, that's the whole point of science. Like, it's kind of sad because I feel like the way we do education, like the way you go through school, you learn science as they present it in school, which we talked about before isn't really 100% right based on like this idea of like the philosophy of it. So they go through school like that, and then they go into research and they're doing science, but like there could be some scientists that don't really understand the like philosophy of what they're doing. They kind of just, you know what I mean?
They're going through the motions.
So and it's not even just scientists, like everyone goes through it that way. So maybe that's why there's like a distrust for science, because they don't really understand what it's doing. They're seeing it more from like, well, people could do things and they can mess with it, and you know what I mean? Like, it might not be real, but if you believe in science, you have to fundamentally believe that we're being so critical of these ideas, that we're putting up to so much scrutiny, that you have to trust the human journey of science, you know? Does that make sense?
Yes.
Okay. Do you want to cut? Okay.